Hi everyone, in this video we're gonna be focusing on multiplexers, specifically on the code in the .phd. So we are basically having the same libraries we have been using in the last videos. We have the std logic 1164, we have the std logic arith, and we have the std logic unsigned. Now, the entity's name is MUX, and it has three inputs that they are A, B, and cell. These here are the three inputs, and we have only one output. That is the case of the X. The cell here is the selector. It's going to switch between these two here, these two inputs. And this is the end of the entity. Now we have the architecture. This is how it's going to behave, the entity we just named, MUX. And X, A when select is 0, else B, and behavioral. Now let's go with the mux.bht. And this is auto-generated, and the only part that we modified is around here, where it says begin, here. And basically we just say that every input here has to wait 10 nanoseconds. In each case, like 0, 0, 0, 0, 1, 0, and so on and so forth. And the last one is 1, 1, 1, and you have to wait as well 10 seconds, 10 nanoseconds, I mean. And that's everything for this part. Hi, so we are gonna quickly see the code for the MUX vector from the 4-bit multiplexer. And we are using the same three libraries as usual. We have the logic 1164, we have the logic arith, and we have the logic unsigned. Now, the entity is named MUX vector, and it has the input A, B, and the selector, of course, and we have the output X. Now, the A and B are vectors, and the X is also a vector from 3 to 0. And that's where the entity ends. Now, the architecture behavior is how the entity is going to behave. And it's 0 when A is equal X. Otherwise, it's going to be B. And behavioral. Now, let's go with the MUX vector.bht. And the only part we are going to modify is from here. And it's just how much time it's going to change from one state to another, and it's going to be 10 nanoseconds for each case. And these are the sequence of numbers, and that's everything.
Hi everyone, so this is the physical part of the project. We are using the Intel FPGA University program, and this is the multiplexer. We have here the input, the two inputs, and the selector here. We have the input A, the input B, and the selector. And this one here is the output, is the LED, number 0. So as you can see, this doesn't work because the selector is pulled down. The first input is not working, but the second input is working properly, as you can see here. We can select up and down, and the LED is going to work when this is pulled up. Now, if the selector is pulled up, the second input is not going to work anymore, as you can see. No matter how hard I try, this LED is not working. And if I turn up this switch, that is the first input, is not working. So this is how multiplexer works. Thank you for watching this video. Hi, what's going on? On this video I'm going to explain the 4-bit multiplexer. We have here 8 inputs that are A0, A1, A2, and A3 for the first part, and we have the other 4 inputs that are B0 to B3, so B0, B1, B2, and B3, and plus the selector, of course. Also, we have 4 outputs that are from X0 to X3. So let's get started. Here, this one, the first switch, the switch number 0 is a selector, and it's pulled down here, it's pulled off. And here, the last switch is the B3. Here, this one is the B2, this is the B1, and this is the B0. Here, this is the A3, this is the A2, and this is the A1, and this is the A0. So now, as the selector is off, the switches B3, B2, B1, and B0 are not working, as you can see. The LEDs are not lightning, but the A3 to A0 are working just fine, as you can see. We can do a lot of combinations here. Now, if the selector is pulled up, the A3 to A0 are not going to light anymore, as you can see. But from B3 to B0 is going to work. It's going to light every LED, as you can see. So that's a 4-bit multiplexer.